cars, roads, buildings, airplane, cities, and all living beings. Everything in this universe has same building blocks, and those building blocks are atoms. But an atom is 99% empty space, and the 1% is the nucleus, neutrons and protons, and the electrons. So, if the building blocks are 99% empty space, then why everything feels solid? Welcome back, my friends. This is the Galactic Hub, and today we will discuss about atoms. So, let's get started. First of all, we have to understand about an atom. An atom is the basic unit of matter that defines the chemical elements. It consists of three primary components: protons, neutrons, and electrons. Protons are positively charged particles located in the nucleus or center of the atom. Neutrons are neutral particles, also located in the nucleus alongside protons. And the electrons are negatively charged particles that orbit the nucleus in various energy levels. The number of protons in the nucleus determines the element. For example, hydrogen has 1 proton and carbon has 6. The interactions between the electrons of different atoms are what lead to chemical bonds and the formation of molecules. Atoms are incredibly small, typically around 0.1 to 0.5 nanometers in diameter. A nanometer is 1,000 times smaller than a micrometer. It is equal to 1 billionth of a meter. For reference, 1 inch equals 25.4 million nanometers. A sheet of paper is about 100,000 nanometers thick. A human hair measures roughly 50,000 to 100,000 nanometers in diameter. Your fingernails grow 1 nanometer every second. And an atom has a diameter of 0.1 to 0.5 nanometers. But why atoms are 99% empty space? Electrons are indeed far away from the nucleus. If we could magnify the simplest hydrogen atom so that its nucleus, a proton, were the size of a basketball, then its lone electron would be found about 2 miles away. All of the space in between the electron and the basketball-sized nucleus is empty. But why the electron is so far from the nucleus is no more mysterious than some of your everyday experiences. Imagine that you tied a baseball to the end of a long rubber band. You hold the other end of the rubber band in your hand and start swinging the ball around in a circle. The faster the ball goes, the more the rubber band stretches and the farther away is the baseball. In an atom, an electron is attracted to the nucleus by the electromagnetic force, similar to your rubber band. Like your baseball, the faster the electron goes, the farther away from the nucleus it is. While atoms are indeed mostly empty space, the void is filled with the electromagnetic fields generated by the electrons within the atom. These affect light waves as they move through materials, preventing them from passing straight through unimpeded. There are 2 ways to explain the solid appearance of everyday objects, which are made of atoms with lots of empty space inside. Because electrons spin really fast. Even if most of the atom consists of empty space, electrons are spinning very fast. To make it easier, imagine a helicopter with spinning blades. When these blades are spinning really fast, it seems like there is a solid ring around the center. The situation is similar in the case of an atom. As electrons are moving extremely fast, the atom seems to be solid, because the structure of an atom is governed by extremely strong forces. Another way to look into this problem is to think about the forces of interaction. When 2 objects come in contact with each other, the electrons in the atoms of one repel the electrons in the atoms of the other. This repulsion, caused by the electromagnetic force, prevents atoms from passing through each other. That's why things appear solid. The electrons in the outermost energy level of an atom, known as the valence electrons, may be shared between 2 atoms, forming a chemical bond. But Pauli exclusion principle states that no 2 electrons in an atom can occupy the same energy level or orbital. Thus, when atoms come into contact with each other, valence electrons are forced to move to higher energy levels, which requires energy. That explains why there is an energy barrier between atoms.